Hi, I'm Craig Stiers. I'm the head of artificial intelligence, analytics, and big data for AWS Asia Pacific. So thank you so much for joining this session. The session today, this one is going to be around automating the business for better efficiency, accuracy, and safety. So let's jump in. Now, we talked earlier about some of the trends that are really driving the adoption of AI and ML across different industries. And one of the big categories is around automating machines, or the autonomous machines, where they can start to make some decisions on their own by learning and being able to have better and better decision making. Now, really what's driving this is the ability to operate at scale more reliably, more efficiently, and more safely than might be the case if it's just a human operator. Now, this applies to more than just autonomous machines like self-driving vehicles. It actually encompasses a much broader array of different types of machines and instrumentation. So let's dig into a little bit around how it actually works on the back end, and importantly, what you can do with this and how you can start to build automation, and maybe even thinking more about what you might do with autonomous machines and in the broader category. So first, we'll talk about how it is that machine vision and deep learning is being used to implement some of these solutions, and then we'll go a bit deeper into some of the other topics. So you may have seen this picture before. This is a picture, kind of love this one. It's in the inside of an Amazon fulfillment center, or an FC. And what you see here is when you order something from Amazon.com and you place your order, on the back end in one of our warehouses, one of these little orange robots that you see on the bottom will drive around and it'll go find a rack. And on that rack, you see there's a bunch of goods, and it's the thing that you ordered. The robot picks it up, it drives it back over to a station, and then somebody who's called a picker takes that item, they pull it off the rack, they put it into a box, it's called packing, and then it goes off onto a truck, and then it's delivered off to you, the happy customer. Now, when we think about from a deep learning and the machines, the first thing you're thinking is we're going to talk about the robots, but we're not. We're not going to talk about the orange, the Kivas they're called, underneath, even though they are using things like machine vision and there's ML models on the back. I want to talk about something that you may not have thought of before. What about the rack? There's still humans that are taking objects off that rack. So there might be things that don't go right every time. So what happens when this happens in a picking process? Somebody's reached in and they were in a rush and they grabbed one object, and as they were taking that object out, maybe it pulled another item that then started hanging off the front of the rack. Well, it's a problem if the robot then drives this back out into the fulfillment center floor, and this object could fall off, it could get underneath one of the robots, it could get damaged. Like, there's a lot of things that we don't want to happen. So how do you identify this? Well, a human could do it pretty easily. They could look at the rack and say, oh, there's something wrong here, let's just fix it. But how do we get the machine to do it for us? So this is what the problem looks like. The rack comes in and it goes in, so there's a pod. And when it first goes in, a picture of it is taken and said, okay, this is what the rack looks like before a person has touched it, before the picker has pulled an item off. This is what it looks like. It then moves over to the station, and at the station, the picker does what they're supposed to do. They take their items out, and then it leaves the station. It moves to a departure station, or departure tower, and another picture is taken there. So at this point, we now know, what did it look like before it got to the picker? What did it look like after the picker? And then we have to understand what should the picker have taken off, and what should the rack look like. So we need to teach the system how to think about that and how to do that correctly. So the way that it's solved is we use Caffe, and Caffe does an image classification. So it can do these maps. It looks within this the bays, the pods, and it says, okay, when I'm looking inside here, these are maybe the pods that are the areas that shouldn't even be touched by the picker. So they should remain unchanged on arrival and on departure. But maybe in the one that should have been touched, we want to look for the type of object that should be missing, make sure that it's missing, and make sure no other objects have been displaced or fallen out, or additional things are missing that shouldn't. So these models are trained and using Caffe, using the machine vision behind that to train those models. So the deep learning, we're able to build this model and improve this model over time. So this is the actual back-end system that makes sure that the products that you order are the ones that you've gotten, and we put in some safety checks to make sure that other products aren't falling off the rack and unexpected things aren't happening within the fulfillment center. So this is just a really, to me, it's a pretty interesting case around, how machine vision really translates into that super fast automation of a fulfillment center and taking away some of those problems that can happen when we start to interact between, say, robots and people and having a lot of different parts to the process. Now, there's this customer called IHS Market. Now, if you're not in the commodities trading business, you may not have heard of them. But IHS Market, they have a really important part of the global commodities trading. Now, when we talk about commodities, they trade in things like steel, they trade in copper and gold, in what you would think of as commodities that have weight and have volume, and they need to be moved around between different continents. Well, it's an interesting challenge. It isn't so much that the moving of the goods is challenging, it's every single point that they touch has a different way of collecting information about what they have in stock, what their inventory is. So all the global warehouses that IHS Market interfaces with, there's no standardization over the types of documents in the inventory management systems. So that's a big challenge. In some places, these warehouses are still operating on paper, on ledgers. They may use fax machines. So they're trying to work in a digital environment with the whole ecosystem of people who are not in digital environments or in a paper-based or really these older sort of legacy forms. So that's a big challenge that they're trying to overcome. Now, in addition, they have to answer questions like, hey, how many tons of this particular commodity are available in this city? Or they want to move from this sort of very reactive view of how many tons of something do I have in this one warehouse to how many tons am I going to have because it's sitting on this ship or on that truck. So being able to really look at the whole supply chain of the movement of commodities, which is something that's been really hard for them to do in the past. So the team there said, hey, we think that there's a way to do better with this. So what if we could understand this, we could process all of the forms that are created, be a bit smarter about what we do with that information, and really start to automate, automate our insights. So here's how they went about it. Most of you wouldn't have seen the sort of back-end process to commodities trading, so let's unpack it a little bit. Now, goods and these commodities could be sitting in a number of different places. They might be on a container ship that's sitting off the port of Singapore. They could be sitting in a truck in Vlissingen, or they might be sitting in a warehouse somewhere in Qingdao. So the goods, those commodities, could be sitting in a number of places in different types of forms and ways that it's communicated, flows back into the system. IHS Market receives those, they ingest it, then they have to take all of that very disparate looking data, digitize it, standardize it, and then communicate that out to finance, to customers, to suppliers, to all of the different compliance officers, all the places that might need to see views of that information. So this is the challenge that they have, and this is the business that they run. Now, what's this? This is called a BOL, or a bill of lading. Now, for a lot of us, we don't work in these industries, so we're not familiar with what these forms look like. But a bill of lading has some important information on it. Talk about source, talk about destination, and it'll talk about the actual goods that are held. But what was interesting about this is there's actually no standard form to describe the goods that are currently in that bill of lading. So if you kind of think of it as it's just free form text, and it'll look totally different from bill of lading to bill of lading to bill of lading. Well, a human can look at that and kind of make some good estimations of what that means, and there might be some codes they can refer to, but it's really hard for a machine to do it in a standard methodology of just doing, say, a standard OCR. So they need to be smarter about it. They need to take all of those bill of lading as an example type of form. They do a digitization. They do an OCR, which is an optical character recognition, so they read all the bits of text, but then they take a very interesting step. They take that and they put that into context based on what they've seen in previous bill of ladings, where information previously has shown up, how it was interpreted at that time, maybe other bill of ladings from a similar supplier, and being able to look at the patterns of how it is that all of those components of information, weights and materials and so on, where those might sit in relation to each other. So again, very highly contextualized information. They then take that and then they start to apply confidence scores. So they say, okay, I think this is a bill of lading, and I'm 90% confident based on what I pulled from the form that that's what I'm looking at. Now, based on that, I'm going to send that form, the digital form of it, down into the system for processing, and then I'm going to do an additional layer of interpretation based on me thinking that it's a bill of lading. So a very important first step, build context, and then interpret it based on that. So they built a machine learning, so they did some instrumentation, and they built a machine learning system that could be automated to ingest all of these different, totally disparate looking forms of information. And what they were able to do, and what they have now running today in production, is they're able to translate all of those old paper forms and very different looking sources of data down into a user interface that is graphical, it is map based. So now a business analyst can scroll on that map and can say, hey, please click on, let's say, a city somewhere in Europe. Let's say they want to click on Prague and say, within Prague, exactly how many tons are available to me, and being able to look at that supply chain of, as more of these commodities are moving, where are they and where are they going to land and when. So really very useful sorts of insights that they're able to push back to the business. And again, by having that very intelligent processing of data, using machine learning based off of past patterns that they've seen on these sort of forms. So I thought that was a pretty interesting case. Now, a third, Pinterest. Now, we talk about Pinterest sometimes, and what people tend to think about in Pinterest is they're just thinking about the results, or they're thinking about being able to share information. But there's actually a really big part of Pinterest business, which is they need to make sure that the pins that they promote or the ads that they're promoting are going to people who are going to be interested. Because nobody really wants to get an ad for something that's unrelated to them, but sometimes you have something that's recommended and you say, oh, that's pretty interesting. Please show me more about that. And Pinterest has a big motivation to make sure that they're providing that right level of placement for the people who are advertising on their platform. So what they found was they host over 700,000 promoted pins. So it's a pretty big task of getting all the right pins to the right people. They were able to, by being able to put the right types of annotations, which is a text markup to describe what the image is, that they're able to improve that by 16%. And the flow through of that, the impact, was that they were able to increase the relevancy of their shopping ads by 68%, their search ads by 34%, and the related pin ads by 18%. So the ability to accurately identify something, tag it with the right text, makes a huge impact to the overall business and really ultimately to the satisfaction of the people who use Pinterest. So how do they do it? Now, we would think, hey, maybe they can just say, well, throw a whole bunch of images and let the system figure it out. But there's something more nuanced. Some things are really hard to describe until a human has said, hey, it's A or it's B. So there's a process, and we call it a human evaluation, so human eval. And human eval is, maybe we look at this dress here, and somebody who knows something about prom dresses can say, oh, this is a short prom dress, or it's not. But a machine doesn't know that until it's told, hey, anytime you see something like this, I think it's kind of one of these objects, or it's not. So what Pinterest does, it takes all the images that are coming in, it makes its best estimation of which of them are related, which ones are very similar, and then once it does that curation and it's created all these similarities, it then goes out and asks, it has a community where people can go up and they say, hey, I'm going to be part of the human eval, and then I get surfaced, I have a task that comes up and says, hey, is this a short prom dress or not? Yes or no, yes or no, yes or no. And so what they do is, instead of saying, please go and look at 100,000 pictures, which a human can never do, they get down to just a very few that are very highly contextualized, that they're pretty sure that they know what it is, but they need the human to tell them. And so this really, it very much amplifies the power of that human decision making by really using machine learning and deep learning on the back end to make that possible. Now, this is just for search relevance. Okay, well, how do I accurately identify objects? But actually, if you think about the Pinterest platform, what makes Pinterest really compelling is it's really visual. But what's visually compelling for me and what's visually compelling for you may not be the same thing and probably aren't. So Pinterest at all times is figuring out, hey, based on the kind of content that you've searched for, based on the type of topic that you're looking to get information about, and based on you, what kind of picture should I be offering to you? So are you going to be looking something where you want a bit more information that needs to have some text markup? What kind of picture should I aggregate and put together on a screen? So again, they do this curation process. They use machine learning on the back end. They collect all the different possible outcomes, and they start doing A/B testing. And so they send it out and they say, hey, I think these are the two things that would probably, like again for this human eval committee, which of these two things appeal to you? And they have a hypothesis, right? So they already believe that they know the answer, but they're testing it. So to that human eval, they say, yeah, I really like what's on the left, or I like what's on the right. And so then Pinterest, they have some very sophisticated ways that they make sure they randomize it. So they take out the people who aren't really they're not really paying attention to the answers they're giving. And they've got some smart stuff that helps filter that. But what they're able to do is, again, amplify that really valuable human evaluation, that instead of just giving somebody a ton of tasks, they give them very highly contextualized tasks. So a very smart and sort of clever way that Pinterest is using machine learning to make it the platform that so many people love. Now, on top of that, what they've done is they said, hey, we've got all these great techniques that we can use, but the average person who's not a data scientist is going to have a hard time just building machine learning models. So what they've built on top is they have something called Sophia. And if you think of Sophia as a way to build experiments, it has the business logic of Pinterest, so that somebody who says, hey, I want to test this new idea, they don't have to recreate all that hard work underneath. Now, and Pinterest will say, and if you hear them share some of these stories, they'll say, hey, maybe building something like Sophia, which is this environment, maybe it's not the right thing for everybody, but what I've seen, and as I've worked across this industry, is that some businesses really benefit from saying, we have all these developers underneath who can build this really smart system, but maybe just building a small layer on top that makes it accessible and contextualized to my particular business. And that little bit of heavy lifting can then make the entire business community within the organization take much more advantage of the underlying smart stuff. So again, Pinterest, a pretty compelling story, and it's a really creative use of our technologies. So what about for you? So we've looked at how fulfillment centers handle it. We've looked in the commodities market, and have looked across social platforms. So how might you use artificial intelligence? Now, in the previous session when we talked seamless experience, we really just drilled in on that top layer. We drilled in on the application services, the vision services, and the language services. So I'm not going to cover those again. Let's drill down from automation. Let's really go down a little bit more into those two layers of platform services and infrastructure and frameworks. So really what we need to think about first is why. Like when we talk deep learning, and in some of the other tracks that you can go watch, we'll really get down into what are the algorithms and what are the best practices. So I'm not going to attempt to cover all of the algorithmic side, but I'll walk you through the process. So if you're not familiar with how deep learning works and how machine learning as a whole works, we kind of start first with data. So this is what you've measured, and it could be pictures that have come in, it could be conversations that you've captured, whatever that data set looks like. Now, in order to use that data, the first thing is you have to have a hypothesis. You have to have some idea of, I think what this data means is something. I think it means A, or I think it means B. Now you'll start to build a model, and as you build it, you start to train it and say, okay, this is my hypothesis. Now I'm going to let the machine start to make this decision, and I'm going to reinforce it and say, hey, you got it right or you got it wrong. So it's called positive and negative reinforcement as the model is being trained, right? So as we're streaming all this data through and saying, okay, yes, this is a short prom dress. No, this is not a short prom dress, and so on. We then have a model that comes out the end of that. So after we've trained it, we have a model that can then predict the next time it sees an image, is it going to be pretty close to guessing, A, is it this thing or is it not that thing? Is it the dress or is it not the dress? So we have a model. Now, the model then has to go to the next step, which is now when it sees an image, it needs to make an inference. So it's saying instead of not just having a being able to give a score, but it's saying, okay, based off the things that I know, there's some level of probability and uncertainty. So from that, I'm going to infer from this model, and I'm going to make a prediction, 85% confident I've got it right. Now, 85%, if you're not from the stats world, you're not sure, like, is that a good number or not a good number? Well, it kind of depends on the case. If you have, let's say, something that's going to be life critical, you want it to be much higher than that. And some other things like being able to accurately capture every bit of something coming off Twitter, 85% is probably enough. So, but we need to make that decision and say, now that we have looked at all the predictions, we've looked at which ones are right, we've looked at which ones are wrong, we can now feed that back as data. And then we start to cycle this. So the feedback data then goes back into training the model. So, hey, you kind of got these wrong. Why? Let's learn from that. Let's tune the model. A new model is created, new inferences. The results of those inferences come out, and it continues into the feedback loop. And this is how deep learning, and this is how machine learning is getting better over time. So when you look at, you see the statement that says, hey, we've got this and it's learning over time, this is how it's working. So there's a hypothesis, a model's built, it learns, says, okay, I'm getting better or not, and then it continues to improve itself. So how does this look like as you build? Now, the diagram here, and just do a little bit of a deeper dive. Most people who are building data platforms, they kind of center in on a design that looks something like this. And if you haven't seen this before, this is roughly called a Lambda architecture. And on the top side, we have where data flows, and we'll call those data pipelines. And on the bottom side of it, we have where events are happening, and we capture those and respond to them. And they're called event pipelines. On the far right side, we have the people who care about the information, the people who want some sort of insights. We'll call those the consumers. And on the far left side, we have the sources. This is where data comes from. It might be your transactional systems, your ERP inventory systems. It could be chats that are happening on social media, and it could be connected devices or whatever your data sources are. Now, data is captured, events are captured, they then flow in and they land into a data lake. The data lake then has some sort of analytics and it has some sort of surfacing where it serves that out to the consumers, and that's the insights that are produced. But that's just the data capture and processing for insights. But what about, where does machine learning fit in? Where does deep learning fit in? Now, when data is captured, before it goes out to the end user, we want to build those models, right? We want to train and build those models. So here's where it lives. Data flows in, it's captured, or events are captured. It now goes through a machine learning and deep learning training process. This is where the model is built. So the model is built here, and then you might take in batch. So you say, okay, these are the images, I scored it, here's the results, and the result sets and the model are published out to the data lake. So that's where the machine learning model is built. So capture it, build the model, and then publish it, and publish the scored data sets. But now we see that next image that comes through, and we say, I want you to make a prediction. Well, where does that fit? So somebody has posted a new picture of a dress, and you say, I'm not sure if this is a short prom dress or not, but I'd like to use my model that I've created. That's going to be in the event layer. So somebody's posted it, which is the event, post a new picture, please give me a prediction, and then tell me if is this a dress or not. That lives on the bottom. Now, when the event comes in, which is posting a new picture, the model is used to score in real time and make that prediction. So the inference is made based on the model that was previously built. So it's published down, dress comes in, says, based on what I know about this, I'm going to give it some sort of score, and then it goes out and an engagement is made. When we say engagement means it could be engaging back with the person who posted it to say, yes, this is a prom dress. Or maybe they're doing a similarity search. Said, hey, find me other things that look like this hat. And then Pinterest or whoever can say, here's other things that are similar. So re-engaging. Now, when we talked earlier about the application services, vision and language, if you look right below the prediction recommendation box, you see something called AI applications. Think of this as the interpretation or the enrichment process. So you might have an event and the person might have given voice commands, or they might have video streams, or they might have image processing. So the AI applications sit here to understand that event, to understand what's happening, and then that feeds back into the prediction layer to say, based on this information, please use the models that came down from the machine learning layer, and then tell me what I should do. So this is how all the bits end up being deployed together in a full platform, in a real production environment. So we've talked about that on the cloud version, which is great. I'm running I'm running some sort of big application. I've ingested all this information. I've built my models. Great. But not in every case are you running everything on the cloud. Let's say you're running something at the edge where you want to build your model in the cloud because you have your GPU instances, you have all the hardware, you have all the technology. But once you built your model, some things, like the scenario we discussed, you want to do the inference in the cloud. Fine. So you've got mobile applications, you have maybe scenarios where you've streamed back in video data. But what about if you wanted to have like our deep lens camera that we've produced? You might want, without having to stream video data all the way back across the network, do some inference and then stream the result back out, you may want the device to be able to make some decisions immediately. So we have inference in the cloud, but we also want to take that model and be able to push it out to the edge. Now, we have a service called Amazon Greengrass, and Amazon Greengrass is the ability to run some code on a very low power sort of chip, relatively, that's sitting within a device. And it could be on a phone, or it could be on a drone, or it could be sitting inside of a camera. So what we want is, we take the models that we've built, the same model that runs on the cloud, and we want to be able to push that to the edge. Now, there's a customer, we saw a video at the keynote. I'm actually going to dig into them a little bit further. The customer's name is Too Simple. Too Simple is a company, they've got a presence in China and also in the US, and they create autonomous driving vehicles. They have cars, they're launching trucks. They've got some really interesting projects that they're working on. But now if you think about self-driving or autonomous vehicles, they have to understand the world of human driving. They have to understand a lot. So in the video we saw earlier, you saw the classification system, right? So you saw the cars driving down, and if it recognizes a car, it says, okay, there's a blue box that's around this, and it says this is the make and model. Fine. Or it sees purple, which is maybe where a person's riding on top of a motorcycle, or there was a cart that was going through that were purple. Or you have pedestrians that are coming across and they're marked as yellow. So that's the classification process. That's fine. So that's one step. But it's not enough just to say, here's the objects. You also want to recognize things like, what does the road look like? Is there anything unusual about the road? And I'm able to do what's called segmentation. So the system needs to be able to segment out in real time, this is the road, and these are the things on top of the road. And if there's variations, to be able to respond to that, just like you would if you're driving. And the third is, there's a lot of different ways that sensors on a vehicle can interpret the world that humans can't. What they're building to is they want to build centimeter accurate precision for being able to control that vehicle. So some of it they do through what we think of regular light spectrums, but they're also pulling in heat signatures. They're pulling in infrared data. So all the sensors that are sitting around that vehicle, as it's collecting information from the world, is able to interpret in real time, say, okay, this is heat signatures, and so based on that, that's what this means. It means that it's this kind of vehicle, or that's a living thing or not a living thing. And so the car can actually get more information about the environment than a human could. So that's another very interesting advancement. Now, each one of these has a little bit different approach underneath, but essentially they're using different types of deep learning techniques to, one, recognize what it's seeing, second, being able to do that segmentation, and third, being able to take very different types of information coming in and contextualize them to be able to really understand what's the environment that this car is driving through. So there's a lot of sophistication that goes within these autonomous driving systems, but it's really that deep learning and machine learning that the car needs to be able to make those decisions to drive more safely, to drive more reliably, than perhaps even over time than humans can today. So what powers this? And we've referred to the GPUs, and maybe, if you're not familiar with GPUs and why they're so important. So what powers computers has traditionally been what's called a central processing unit, a CPU. And a GPU is a graphical processing unit. They were created some time ago to power video processes. But what GPUs are really good at doing is they have lots and lots and lots of processing cores that sit on that chip. and they're good at taking a problem that comes in many, many small parallel parts and answering those simultaneously. And so GPUs have become really the tool of choice for being able to take these mathematical models that happen to work really well when you break them into a lot of small parallel parts to run simultaneously on the chip. So it's this really nice match that's happened over time that is neural networks, and as you have all your different types of deep learning algorithms and ways that they're processed, and GPUs, they come together really well. So as we've released, we had our P2 instances. Now we've got our P3 backed instances. Customers are able to use the most powerful GPUs in the that are available in the market to run these sort of the model training and building. And in addition, what we're finding is that the only constant is change. Right now, TensorFlow has got a lot of resonance, and MXNet within, for scaling out, say, recommendations has got a lot of resonance. But within the academic community, PyTorch is really popular, and you'll find some customers really like using CNTK or Gluon, which is the abstraction layer that we've just recently released that helps you build deep learning models without sacrificing performance, but at a higher, more abstracted layer. Well, that's what we see today. It's really hard to predict the future, and in 6 months or 12 or 2 years from now, knowing what the platform of choice is really hard to predict. So what we're doing is, for our customers, we will give a single-click deployment for all of these. If you want to use Cafe 2, you shouldn't have to worry about knowing what to install and what drivers and configuration and all that mess. If you leave that to us, you launch an AMI, you just have that, an Amazon machine image, you just have that environment up and running immediately. Now, if you put these two together, you're able to launch your platform of choice, and you're running on top of the most powerful GPU instances. It really opens the door for any of your developers to be able to build with the best interfaces on the best platforms. Then we also have the release of SageMaker. And SageMaker is this idea that, hey, not everybody is a TensorFlow expert. Not everybody is a Cafe 2 expert. So what if we help take away some of that lifting of data processing and setting up the environments and training and deploying and maintaining and monitoring managing the infrastructure, and we gave something that was a fully managed service around that helped with the build, helps with the train, and helps with the deploying and running those models. So that's what SageMaker is, and a lot of our customers are really excited that this is out in the market because there really wasn't anything like this before. So, again, putting together those bottom kind of layers of the stack, I think the opportunities around automation are really going to just increase from here. I think we'll see a real acceleration going forward. So to wrap up, we've talked today, the previous session we talked about some seamless experiences. In this, we talked about autonomous machines and some of the really interesting sophistication that goes into making those work the way that they do, and then the bigger story around automating the business. In addition, there's a whole nother domain around scientific breakthroughs. We're seeing some interesting stuff around mixed realities that's coming out too, virtual reality and augmented reality. There's even more exciting stuff that we see coming around 3D printing and creative design. We see 3 big cases here, but I think over time, it's going to kind of be limitless. The things that people can do when they're able to take the creative ideas that they have, and without that time and without those barriers, they can start to deploy and use applications that on the back end have this really powerful AI backing them. So with that, I want to thank you very much. If after today you're wanting to take your AWS knowledge to the next level, you've got several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes and learn how to design, deploy, and operate highly available, cost-effective, and secure apps on AWS. And finally, don't forget to validate your tech experience with AWS and use practice exams to help prepare you for the AWS certifications. Thank you for attending AWS Innovate. We hope you found it interesting. A kind reminder, please complete your surveys and let us know what you thought of today's event and how we can improve this event experience for you in the future. Thank you very much.